I expect good behavior and don't be mean. So this is the Konveyor community call, and we have some things to talk about. And I wanted to start by welcoming new members. I don't see in the people list names I don't recognize. I've seen these names before. But if you'd like to say hello, now's a good time. I struggle with awkward silences, so we'll move on. The next thing that we have on the agenda is demos. The first one that we have is, oh, you know what? It looks like I'm sharing my screen from my perspective, but for you, it does not. So let me do that. Nice. And now it's gigantic. Can I?
Yeah, actually, it looks pretty small. There you go. Okay.
All right. So I'm an expert at hosting meetings. All right. So the first things first is Mark and demoing application migration team update, the Crane stateless overview. Take it away.
Thank you. Let me share my screen. Yeah, can you see slides? Yeah, hopefully.
Yes.
So I would like to provide update from application migration team, and we are focusing on the Crane tool. So it will be about migrating Kubernetes workloads, and so far it's stateless. So first, let me remind the basic approach which Crane tool originally used, and we continue on using that. And that's turning live application from Kubernetes cluster into the manifests to be able to deploy on different cluster or in the GitOps. 3 steps we follow are first export, then transform, and then apply. Export is responsible to connect to the source cluster, dump YAML manifests, and that's it. Transform prepares changes or like necessary modifications of the manifest in order to make them deployable on the target cluster or to do some required changes. Then we can proceed with apply, which takes exported resources, transformations, and create output manifest, which can be deployed in the kubectl migrate command to kube Kubernetes cluster. We follow some principles like it's not destructive. All input output is written in the disk. There is no change on the source cluster. All this flow should be repeatable. Once it could be executed more than once and should still provide the same result. And the result should be GitOps ready, which means we can put the manifest to the Git and deploy, for example, with Argo CD or tools like that. Currently, for this phase, we are focusing on stateless migration. That means resources like deployments, config maps, etc. We skip for now persistent volumes data, so this will come later. Now let me focus on each of these steps a little bit more deeply. So first, export wants to capture state from the source cluster. We have Crane export command, which does that. A typical result is a set of resources or YAML files within the directory, which is called export and then structured by the namespace name. What is new and what we are currently working on or is in the progress, it's cluster level resources. So if there is namespace resources which have some references, for example, to cluster role binding or generally to cluster level resources, Crane will be or is able to download them if permissions allow. As already mentioned, we don't dump PV data or like data from the stateful. Next, about the transform. So the transform prepares like kind of modifications for the exported data. We introduced new 2 concepts here. Originally, there was a set of JSON patches which were able to modify or clean the exported data. We took these patches, wrapped it in the customize, so it allows like a more friendly way or more ways how to modify this data. Then we also introduced something called multi-stage principle. So the whole migration or transformation doesn't have to be the single stage. We can have some plugin-based stages, then some custom stages, and each of these stages can go step by step. So the result should be inspectable, easy to debug, and powerful solution. Currently, there is some default plugin which is executed by Crane Transform, but we're also working on accepting instructions file, which will make this or even more complicated transformation easy and to be able to execute it with a single command. You can see example of some custom stage which shows what Customize can do with changing namespace, for example, or images. Then we have exported data, we have transformation, so we can run apply, which generates final manifest, which can be deployed to the target cluster. For this purpose, there is a crane apply command, which performs it. On the final data, there is another new command, which we are working on, and that's called crane validate. It supports API validation against a target cluster or API definition file, which is suitable for offline validation. And in the end, this data could be deployed to the target cluster with kubectl apply. I think that was pretty much it. Currently, there is no demo. It will be next time, hopefully. Now there is open enhancement, so if you have time, please take a look. And just for information, we're still working on mictools/crane repository. Any questions? So thank you.
That's having worked on that previously, it's really cool to see that resurrected and new features being added. So I'm excited to see demos. Savitha?
Yep. Well, I'm going to take the screen away from you. Okay, let's see. Can folks see my screen? Perfect. Okay. Yeah. So I don't have such polished slides like Marek did. It was awesome. I used Claude to put this together in 2 minutes. So bear with me. So I just want to show off what I have been building for a while now. I've been tasked with creating rules generation for Konveyor using AI. And I am predominantly using skills as the entry point, and this would be like bundled or packaged or distributed as skills. And part of the challenge was, one of the challenges I felt was like when a migration guide is given to the LLM and say like, hey, this is the rule schema, and we do have a rules.md file in the Konveyor analyzer, LSP repo, and you give that and you say like generate the rules, it was not always valid rules. It did create rules that was syntactically accurate, but it was not creating 100% functionality. Well, like it was not 100% functionality. So I've been trying to bridge the gap. I wouldn't say I've achieved 100% functionality, functionally valid rules, but I'm getting there. And I want to show you, take you through the process of what I've done so far. And I have a little demo to show, and we can chat after that. You can all tell me if I over-engineered it or if something is missing or something's not missing. But before I start, I just want to give a shout out to Wanma. Wanma has been helping me with validating the rules that's being generated by this rules generation. We have this Spring, I think there's an Apache HTTP client 4 to 5 migration. And he gave me that link, and I've been like going back and forth. His feedback's been very useful, and I'm hoping that we'll be able to use this pipeline to generate more rules. Okay, so this is a pipeline. The way that it is built is like it has a few skills. There are like 4 skills basically. One is an orchestrator skill, and that is the main agent that wants, and then the rest of the skills are like rules writer skills that extracts the pattern, and then there is just test generation, generates test data for us, and then there is a fixed loop validation agent. So all these are skills, but they run as sub agents so that they don't take the main context, and don't cause context overload or context rot, and they report back to the main agent. For the deterministic portion of it, like I'm only using LLM to do the creative bits of it, like, oh, I give you this guide, extract me the patterns and stuff like that. But I am using Go code here to construct the rules and to merge or verify the rules if they are valid, and like test report. All the other things are not handled by LLM. It's all added by like Go code, and that's why that I feel that that's more reliable than letting LLM do everything from scratch. And I do have I learned one thing when I was doing I just did I had these pieces put together, and I was like, when a stage is passed from, okay, I'm going to extract this guide. I have extracted the patterns from this guide. I'm going to construct rules from this patterns and everything. I realized that there was like this input-output format that was lacking. So I created something called like a contract. So in the skills, I mentioned that these are the input fields and these are the output fields. And I have a Go CLI to like very small command that's written, and that goes and checks the contract, like whatever that we get back from LLM, is it valid? And then I can pass it on to the next stage. If the contract fails, then we rework and make sure that the output that we get from LLM is in the format that we want, so that we can proceed to the next stage. This is the end-to-end flow. What happens is like, as a user, I pass a migration guide, and then like these blue sections are like handled by Go code, and then only the gold or the however that you are able to see, it's supposed to be gold, conveyor gold. So these are the agentic flow. These are the ones that are handled by the skills, the agents. First thing is that given a migration guide that is an HTML page or whatever, what the first step is that take that HTML page, convert it into a markdown, separate it into sections, because the guide can be so huge and it can have headers. And for example, if you're just giving it a GitHub page, it has like a lot of side nav and stuff. So whatever happens here is that it strips out all the data. It only takes the meat of the migration guide, and then it prepares it, and then it divides the sections. Like, for example, if the guide is like 4,000 lines long, it's too much for one LLM agent to handle. So it divides it, and then it gives it to this rule writer agent, which basically I need to rename it, extracts the pattern from the guide. And when I say it's n, like I have configured it to use anywhere between 1 sub-agent to 5 sub-agents, the maximum. So based on the number of sections, the LLM, the orchestrator agent makes a call that, okay, let's just spin up like 3 rule writing agents for this given migration guide. And then it spits out the patterns, and then this pattern gets, these are all the Go code, like the patterns get merged, verified. When I say verified, this is another stage that I added like in the past 2 days. For example, like I'm mainly tested with Java right now. The LLM, when it even extracts pattern, it still makes up things. There are a lot of false positives. So what I'm doing is that when it's extracting the pattern, it can reach out to Maven Central, and then it can figure out if the dependencies are valid or not. And then the verify step, like there are like this JDK tools, like it downloads the jar, and then it just checks if the FQN are like valid or not, things like that. I'm trying to add a little bit of more deterministic approach here, if we could verify or not. And I think if we are in an air-gapped environment where these things cannot be done, it will just fail gracefully and move on to the next step. But we cannot just like guarantee like the 100% that it will not have false positive at all. Once the patterns are verified, it will create the rules. This is also done by the Go code that I have deterministically. It will, based on the patterns, it will construct the rules, which helps with the syntactic validation. The YAML files are valid, and then like just another layer of validation here. And then I do have another, once it's validated, the rules are created, I have another step called coverage, because LLM sometimes doesn't extract all the, so for example, a guide has 27 patents, sometimes LLM only does like 20 patents, and it doesn't extract the rest of the patents. So I have a little check there to compare if it has extracted everything or not. If it hasn't, then just pass the portions that it has not extracted back to the rules extraction loop right here, and then it comes back with whatever, runs the coverage again, and until it finds that all the patents have been extracted. Once it's done, it'll stop for the user to prompt if they want to go ahead with the test generation or not. I kept this step because if someone wants to just do a POC and they don't want test generation, stuff like that, they could just exit here saying like, no, I'm done. Just give me the rules and I'm good to go. But if someone is wanting to create the rules with the test generation, for example, like I said, I'm hoping the engineers who want to contribute to Konveyor rules, its repo, they would also want to contribute to the test data. So they can go ahead to the next step, and then it will create the test data for you based on some of the strategies and based on the rules and some of the skill data that we have provided. So I also have language specific references and strategies for generating test data, generating rules, and validating rules. So it'll check that particular language, how it needs to construct, what's out of scope for it, and stuff like that. Once it knows all these things, this is also like a parallel sub-agent loop. It decides like, okay, I have like 20 rules. I'll just create 2 test data generation sub-agent loop. It goes through that, and then it creates a set test data. This sanitized loop just checks for the XML validation. Sometimes the XML stuff that's generated is not valid, so it goes through that loop. And then I use Cantra to test the data that's generated against the rules that we have. And this Cantra I'm using from the main branch right now. I used to run local, thanks to Emily and Wanma again. It previously I was just using Cantra test that was spinning up Java containers for me, and that was taking like 2 hours or something. But now I just use run local, which is able to take advantage of the Java provider that I have locally, and also the JDTLS, stuff like that. It's all already there in the .Cantra folder for me. So I might be wrong. Please correct me here, Wanma and Emily. But that's what I'm using. So run local just runs all the tests super fast for me, and then flags what test has failed, what has been passed, and then it goes through another validator loop to fix the test data for us. It will never fix the rules because I don't want it to fix the rules to pass the test. So whatever rules it has generated, it tries to fix the test data. If it goes through one iteration, if it's not able to fix, it's just going to report saying like, hey, this rule failed. So it's on human to verify all the rules anyways that it has generated, if it's valid or not, but it spits out all the report and stuff. I'm just going to pause here. I know I just rambled. I'm going to pause here to see if anyone has any questions. All right, then. I'll just quickly show what I have. I recorded this because it was 20 minutes. And I'm also really sorry that I might realize the font might be too small for folks. Let me see if I can increase the font, but it'll just make the video go out of scope. I'm sorry, folks. I hope you all can see, though.
Yeah, I can still read it.
Perfect. Okay. So I'm just going to call the skill that is generate rules skill, and then I'm going to pass it a migration guide here. This is the migration guide that I've been working with Wanma. So this is the latest I've been using. So I just used that to record the demo. So what it does is that it first reads the agent, the skill, and then figures out what it needs to do and stuff like that. Once it's done, it kicks off sometimes it creates a nice to-do list, sometimes it doesn't. So it depends on the agent's LLM's mood that day or the time that I'm recording today, it didn't do. So never mind. It's just ingesting the guide. I also have chunking because some guides are really, really huge. And what it does is that it will make sure to go and split it into sections so that we are not only getting partial data. It goes and tries to create the guide, and then it realizes that this guide has 5 sections. So what it's going to do is like it creates like 5 different calls and then ingest all the 5 different guides from that page. These are like sub pages, so it's just ingesting everything. And once it has done that, it will create the guide for me. It will combine everything. Once it's combined everything, it will, okay, let me just go back. Once it's combined everything, it will create a contract to kick off the rule agents. Okay. Okay, so you can see like it is creating like 3 contracts because it thinks that it needs to spin up 3 agents. It's at the discretion of the orchestrator agent. It creates 3 rule writer sub agents, and it doesn't. You can see like these are like sub agents. Spins up on its like own context and everything. All the details that's necessary for it has been provided, and it works on its side. And then it once it's done, it reports back to the main agent. Let me just fast forward because it takes a little bit of time to finish. You can see like the rule writer 1 has been completed, 2, 3 has been completed. It'll like print how many patterns it has extracted and so on. The second agent was taking a while because that was the meaty portion of things. Okay, so you can see like the rule writer agent 2 was also completed. Once it's complete, what it does is that it merges the patterns and then it goes through the verify loop. This is the one that I've been experimenting here, which I talked about, like the Maven search and the using the JRTF tool to find the fully qualified names and stuff like that. So it'll print stuff here, what it has verified, what it has not found, what it has skipped. It'll skip the built-in .xml rules or the patterns and conditions. So it just says like it's skipped. And it gives us a little bit of confidence level on what it's trying to do. And once it's done, it's going to validate the rules for syntax errors and stuff like that. And after that, it's going to go through the loop again to see if it needs to, if it has missed any coverage. So it's running a coverage check. It passes the entire guide, the patterns that we have, and it will see if we have missed if the agent has missed any section, and if it determines the agent has missed some sections, it will send that again to the rule writer. So it realized that 8 sections with uncovered artifacts, so like sending the gaps to the rule writer. So it sends that particular portion again to that agent, and then it will go through this loop of creating the patterns and rules and merging that for us. I'm just gonna fast forward that because it takes 3-4 minutes based on how fast the LLM is. So like right now it found more let me just pause it. So from that it finished the extraction. It found 2 new patterns. It's merging the new patterns back. Again, it goes through the verification loop, and then it goes through validation loop, and then like rerunning the coverage, and then like it will realize that there are no more gaps, and then it will wait for the user to prompt like, do I want to proceed with the test generation or not? So like once I say yes, continue, then it will proceed with the test generation. What it does, it takes the rules that we have, and then it divides it And then spins up to, first it's scaffolds. The scaffold is nothing but it's just creating a folder structure for us. Once it creates a folder structure, then it will divide the number of rules and then passes it to the subagents. It's decided that it's going to do 2 subagents here. So you can see, like, again, we'll go through the contract first because I want to verify the inputs are correct, that whatever the inputs that we are passing to the agents are correct. It'll go through that loop. Once that is validated, it will spin 2 test generator agents. And then it'll do its thing on the side, creating tests for every single rule. And you can see, like, there are 2 test agents here. It takes a time. Sometimes it depends on the number of files. It batches it. Sometimes it batches it based on the group. Sometimes it batches it like, oh, I have like 20 files. I'll just do like 10. It's like non-deterministic, determined by the LLM in that moment. Once that is done, I'm just going to fast forward a little bit. Let me just go here. Sorry. Okay, so the test generation is complete. Test generation is complete here. It's validating the XML path and everything that has been generated, if there is anything. And now it will run the test. This is where it calls Cantra locally. This command, it's gonna run the Cantra test locally, so you can see, like, it's gonna go this loop. It's really fast because I'm using run local. When it takes, like, it depends on the number of files. It takes like anywhere between 3 to 10 minutes. If I have like 90 rules or something like that, it takes like 7 to 8 minutes to run everything for me. So it ran everything. 21 of 23 passed. It realizes 2 failures. So what it's going to do is it's going to kick the validation loop to try and see if we can fix the failed test data. So that's what's trying to do. It collects 2 failures, and then it will pass the failures to the rule validator fix loop. What it takes the failed data, and then, like, it will look at the logs and stuff like that, determines why it failed. Here I also have some fixed strategies for Java language, like, oh, if you see these things, these are the things that you can try. That way I'm providing LLM with more context on how to fix the test data. It'll go through that loop, and it will do 1 iteration. It'll see if it can fix or not. If it's not able to fix it, it's just going to report saying that, hey, I ran through this, I fixed XYZ number of rules, and then I couldn't fix these. And that's it. So it creates everything. It reports. It prints a nice summary here, and then it says where the rules are stored, where the test data is stored, and just gives us like a report.yaml. So this is going through the motions of trying to fix the rules, run the Cantra test to see whatever fix it added works or not. In this case, when I recorded the demo, that it was not able to, but I was kind of happy with it, that at least I could show a case where it also, sometimes it says like I fixed everything is working just fine. But this is one of the things when I recorded like just 20 minutes before that it could not fix it. So it said like, I'm not able to fix it, it fails, like, and it'll just go on and print the report. I originally had 3 iterations. I figured that that's too much of like it was like too much resources it was taking. So I just have 1 fixed iteration right now. It can be configured later. Like as you can see here, I'm sorry, I don't know how to make this go away. It's just preventing a lot of things. So you can see like it says like 0 fixed, 2 still failing. And I just have this Cantra limitation. It's nothing, but when I try to run it in Sandbox, I don't have the run local. So I just needed some kind of debug information printed out there. So it says it failed, and then it's just going to create a report for us to see. what is the input, basic things, just to say like how long it took, how much time each step took, and where the outputs are stored, and what like the rule categories and stuff like that. I also want to show the rules that it generated. So this is the output directory. If I do a tree, I think it's going to be crazy. Sorry about that. So let me just do a tree of rules. Sorry. When someone is watching, I cannot type. Okay, so we have like one rule set with YAML. Let me just open that. YAML. Just a basic rule set, whatever we have. We can improve on all these things. These are based on how much knowledge I have. And I am planning to work with one more to improve these. Let me just open one of the files to show what it has generated. Like you can see, oh, this I can maximize because it's in my terminal. Okay, so you can see like it has generated like a role ID description category. Effort is like, it's again like based on LLM. I have provided it a complexity matrix, but this can be tuned much, like these things can be tuned, labels, and then like in the message it says before, after, if it has an example, and then like links, and then the condition. So one of the things that I have to do is like I have to make sure the description is not super verbose. That was one of the feedback that I got. I'm going to work on that, and I'm going to keep working on iterating this. But this is what I have so far. Just want to pause and wait for thoughts, questions, comments after my 10 minutes of ramble. I'm hoping that at least it kind of like bridges the gap where someone doesn't know how to write a rule, then it can just at least create 70%. Even if it creates 70% for me personally, as a first goal, I feel like that's like a big deal, because I used to spend days trying to write the rules, fix the rules, and then I'll involve one month, and like I'll take a cycle. So I have gone through this motion, but to see something that's getting generated like this is like a win for me. I haven't tested other languages. The next is that I have language specific details. The next thing is like Go in Node.js, TypeScript, and then the last one I'll test would be like C#. And I also noticed that Cantor supports Python now, or I did notice somewhere. So I also added those specific strategies and stuff like that too to the skill for Python. But I don't think we support Python yet on the extension.
I think it could be like a good idea to put this in the Konveyor ecosystem project. You know, I mean, it's as you keep working on it, so that we can, take a look, or people, whoever is interested can take a look, and maybe we can contribute some PRs or whatever. But it looks like it's. I think it looks like it works, right? So.
Yeah, I'm going to put it in the rule sets. I just wanted to wait until it was at a decent stage where I showed it, or I know, because I was iterating really fast every day, committing and trying things out. Today or tomorrow, I will move all these things to the rule sets repo, create a PR there so that we can have reviews and iterate over there.
Cool.
Yeah, until then, I can even put where I have my stuff. I'll just put it in the agenda. I'll also put it in the chat. Put in the chat now. Once I figure out the.
Have you like run it against any migration guides for rule sets that we already have high coverage of to compare?
I don't have a migration. I think those are all written by. I need to find the migration guide which was used to create the rules. Then I think that would be good.
Yeah, I think that'd be
So-
really interesting. I'd love to see what the difference is between the human created ones and the generated ones.
Yeah, and I tried a few things. I tried a bunch of things like trying to evaluate. I tried to find the real world. Like I was testing with a Spring Boot guide, Spring Boot 3 to 4. I think that was the one that I was using. It was like really long, 4,000 lines, created about 90 rules. I was trying to find the apps in the wild. I could not find a lot of application that would, so I had to find 4 application that would cover my 90 rules. So like it was like that. I could not find one application that would trigger a lot of rules. I did find the rules being triggered, but I also didn't have the time and the energy to go and spend each and every rule, is it valid or not. That's something that I feel like I need to do. Again, LLMS. We can use Claude to generate those applications. Maybe that would also be nice, but sometimes it makes up, so if it knows the rules, right, it makes up the test data. So the test data is not 100% accurate or efficient because it already knows the rules. But I can always say like, use another, without even providing some background context or things like, hey, create an application from this to this, and I'm hoping you migrate or things like that. I can try that out. This has definitely helped bridging the, like, at least for the test data portion, that LLM is really, really helpful. Oh, I also forgot one thing. So this skills can be run, like I have used OpenCode to run the skills, works. I've used Goose to run the skills, it works. But Goose is so slow, I need to go and debug because I don't know if it can do the way that I am probably invoking the subagents, or like the way it's codified, it's not correct. It takes like, it has a 5-minute timeout for every subagent, and then it takes like really long time to complete even the extraction step, but it completes it. If Claude and OpenCode takes 20 minutes or like 15 minutes, Goose takes 1 hour to complete. Works with Goose. And these 3 are the ones that I've tested. I need to test with Cursor. I need to test with anything else that we want to, or just as a matrix that where it works.
It was a very, very cool demo. Right. It's exciting to see that coming together. I know like rules writing has been well, I don't know for certain that I've seen anyone write rules on their own. So it's nice to see that we have a way to move that forward. Hiteshwari has some discussion on the Goose powered migration harness.
Yeah, so hello everyone. I don't have any fancy slide stack because I wasn't planning to do this, but I just decided 30 minutes ago that I would still show what I have. So I just put in the bunch of screenshots so it's just easier to talk. So I'll share that, and then I'll share my terminal just to show like how it's working. So let's do that. All right, so it's a simple Goose powered migration harness. So it is divided into the 5 steps. So the first one is detect. Second one is the plan, execute, verify, and compile. It's like the software development lifecycle. So the detect step basically does is it goes and scans the project. It doesn't read the source file, but it's try to look for the builds and dependencies and try to see like try to scan the patterns and outputs into the detect JSON file. And with that also, I don't have this in this screenshot, but I was looking into Shaf's work, which is MakeIQ, and I also realized that he's using Grafify, and I think that's really cool. With the Claude code, it is a skill, but it's an open source project that basically creates a graph of a code base, and it tells you like what depends on what. And I think creating planning, that was really helpful. So I also implemented that, and using that, it basically creates like the overall scanning of the project, not going so much into detail. And that is being fed to a skill registry where I have like 5. Each step has its own skill, but for the planning, it has a one root skill, which is migration planning. And based on what detect.json provided, based on that, it will fetch the reference skill. So reference skill it's basically the library of bunch of skills. And based on that, for example, if I have a cool store app, which is the goal is I am trying to migrate from Java EE to Quarkus, and my detect step already said that, okay, we have this technology stack, we found it. So then migration plan skill would go look for that, and using that, it will create a plan. And I just recently ran a small test on it. So I'll share my terminal next. So basically, here I am running, and all I'm saying is that migrate to Quarkus 3, and it detected like manifest what are the files available. And then, as I said, Graphify, I just implemented that yesterday, so I still have to do a lot of research with that, but it created a nice graph that shows like which file is dependent on which, and which class or which file needs to be migrated first. And based on that, both of this detect JSON and graph JSON is being provided to the planning step, and planning step takes the actual root skill, which is called migration planning, and then it also finds the migration references, which is Java EE to Quarkus, and using that, it creates like 33 steps. And this is how this planning README looks like, and it's pretty detailed, and I was impressed that what it did for Java EE to Quarkus. And it writes down the goal, and based on the complexity, like what needs to be solved first. So for example, if you see step 1, it says depends on none. But when you go to step 2, it says step 1 needs to be done first. So the next step on this harness is execute, which will solve step 1 first, and then go on step 2 and step 3 and things like that. And it will go at the end, like all the way to like last step, which is step 33. And it will say like, oh, depends on step 5. Like this needs to be done before you go on to step 33. And then it'll try to compile and go on a loop for 3 times to see like if it's running or not. And it's gated by approval. So if you say no, then it'll rework on it. I still need to work on where I can provide like feedback. So it takes the feedback. Right now, I just have like a yes or no, but I think we can make it like we can communicate, hey, I don't like this particular step. You can go more do research on this one. And maybe we have like a better plan if you don't agree with it. So that's what I have.
Trisha, this is really cool. I'm curious, like, so does your actual harness, is it language agnostic?
So that's next thing I'm going to talk about. And this is the reason why I didn't want it to present it today, is because it's not language agnostic. And I realized that yesterday, and I was doing more research, because when I give like a nerd dinner, it would fail. It wouldn't give me this accurate plan. So this is my next goal, that the migration plan, the very root first skill, needs to be language and framework agnostic. And that's why I think Graphify would help, is because regardless of it, it will unwrap the project step by step, and it will tell you, like it will give a migration plan that, hey, this is how this project or this application is designed, and this is how we are like willing to migrate. And hopefully
I was going to add to that. I don't. I've actually been curious the more that I've been playing with this. Maybe just like how we have providers, right, to providing analysis and has language specific details. Like it might not be crazy that we have different harnesses per language that we support in Konveyor, because I mean there's just some stuff that I feel like would be useful to be self-contained in the harness that might be language specific. I guess I would be curious what you find if you compared rewriting this to be language agnostic versus the one that's working really well with the Quarkus migration, because this would be something that I would think might be interesting to get notes on, of like, well, actually it was really helpful to have success criteria clearly defined for this language with here's all the Maven compilation commands that I expect to succeed, blah, 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 right? I don't know the answer to that. Maybe I'm sure like Opus is really good at figuring that out, but maybe not on like a cheaper model. I don't know.
Yes, and that's also my another goal, that I want to see that each skill is model agnostic or not. And one thing I don't know if we can add is like we can add the reference. It's like the library of skills where we can add a bunch of skills for different languages, and maybe the migration plan can detect and say, okay, this is what we have, and it fetches and it can create like more specific plan. That's what I'm visualizing right now. I don't know how this is going to be in future. Like I'll test and tell you, but that's the goal. Yeah, anyone has question?
Actually, I think that this is really awesome progress. I know that it's discouraging to not be able, that it wasn't agnostic, but I think what we're probably lacking here is knowledge in how to construct these skills in such a way that they can provide a comprehensive solution to a migration problem. So I think us gaining more knowledge in here is a good thing. So yeah, like I agreed with the things that Dylan was suggesting, as far as maybe we can't be so language agnostic and we have to have some opinions. And I think having some experience there to back up what we say, I think is important. So this is really good research. And I think what a really good thing to do would be to capture this in a GitHub issue somewhere, so that we have it for, it's not just lost in a demo video.
I wanted to understand how the specific skills under references are invoked. My understanding was that references, like anything under a skill.md file that you put under that references subdirectory, will not be recognized as a skill by Claude. So if you list all the skills it has access to, it always has to be at the top level directory.
So currently what I'm doing is, it's based on the detect step, it creates the recipe, and recipe file is accessing, but I need to go look into it just to see like if it's actually invoked or not. I think I am printing somewhere that it is doing it, but the recipe is created by right after the detect step. So I think I need to go look into the logs and see if it's invoked properly or not. But
okay,
I didn't notice that. But I thought it's invoking because there is a step where I'm printing out and I didn't look into detail. But it says reference is baked in. So I think it is doing what I thought it's been doing, but I will look into more detail.
Claude is lying to you. So never know. I can see that. I'm just imagining all the ways that Claude has lied to me and made me think that it was doing a thing, and it wasn't. What was it? Most recently, some detection. It created a flag, and it made it look like it was doing what that flag was there, but the flag was meaningless. But it just left it there. So these are all like really good things to for us to research, and it's exciting to see that move forward. The roadmap is up next, and I think that is you, Dylan.
Yeah, I just wanted to call out the dates for 010. The feature freeze is about the end of the next sprint. So that's obviously going to bleed into what the high level goals are, is finishing all of the hitting feature freeze for anything we've committed to 0.10. I did notice actually there's a couple enhancements still open on the 0.10 milestone that I think we're kicking. So I just need to go and update that. But I listed the high level features here, right below under high level goals. Feature freeze 6.3, blockers only 6.30, code freeze 7.7, and then GAing this thing on the 14th of July. The timeline might be able to be expedited. I don't know. It feels like we're ahead of schedule on almost everything that was committed to 0.10, but I'm going to keep these dates as is right now. Questions? I guess I'll just ask if there's any questions on the high level goals. The other thing I want to call out is we've already been discussing for 0.11 supporting agentic migration. So that was one of the enhancements that David, I think he just put in the chat, that was listed for 0.10. We want to extend agentic migration support across the rest of the project. This is kind of what Hiteshwar was demoing. There's some work that a few people on the team have been putting together to get the agentic migrations running from the UI. I was going to demo that, but it's just not where I want it to be yet. So I think I'll do that next community meeting. The point is that by the end of the sprint, I really intend to have an enhancement submitted for 0.11, since it's going to be a pretty significant effort that I want to make sure we can have plenty of time to do the design process for it and get some feedback on it. So all of that's going on top of the other work under each subgroup. So I don't know if there's any questions, comments on the upcoming sprint. Cool. David, if you're back, you can probably scroll down to open discussion. I can just talk about, let's see, who's up first. There's no one, no open discussion topics except for the next meeting host. So someone's got to volunteer to take it off of David's plate next month or in 3 weeks. And this is where I mute my microphone and wait for someone to volunteer.
I'll do it.
Thanks, Savita. I was hoping you're just too uncomfortable with the silence.
Okay,
too.
well, if Savitha's going to volunteer, I'll volunteer instead of Savitha, because Savitha's run like 1 million of these, and I've only done it once. So I'll take it over Savitha.
Thanks, Fabian.
Thank you.
I should have muted her microphone too, is what I should have done.
Oh, wait, we have a new volunteer. Her mic is in.
Dylan.
Emily volunteers.
Yeah, I was, Dylan was spot on. I was so uncomfortable with the silence. I was like, okay, I'm just going to do it.
Okay, Emily is the victim. Thanks, Emily. That's it. Any other topics while we're together? David, I'll let you close out.
Oh yeah, we did such a good job. Yeah, the best meeting ever. It was great. Thanks.
Hey, at least you
Thanks,
remembered to
everybody.
record it. You did better than me.
Yeah. Well, I can't think of any good joke that's also appropriate while I'm still recording. So, on that note, everyone have a great day. See you in a few
Cheers.
weeks.
Sounds good.
Bye.
Bye.
Bye. Thank you.